So tonight, I'm sure a lot of you guys out there know about direct venting. You probably see it pretty regularly, especially in the houses you inspect. But I thought I'd touch on it a little bit just to remind everybody about some of the setbacks and distance requirements and so forth, and do a little bit explaining. Not a lot we can do in what we call a Mike's moment, which is basically a moment. So anyway, let's get started. Direct venting is venting that has a direct access either through the roof via the attic or through an exterior wall, where you can get rid of products of combustion from burning whatever it is you're burning, and have fresh air, or what they call combustion air, come back in to where the fire is located. That's basically what direct venting is and does. Here we go. A side view of what some of the components are. In the case of a exterior wall, our vent goes out through the wall, of course. Products of combustion go out that vent, and fresh air is invited back in via that same access point, separated by a piece of aluminum or piece of metal usually. And on the right, if we're going to be doing it through the attic via the roof, we're going to have it go straight up instead of sideways. Direct vent appliances actually heat air, as you can see by the blue cold air down here, being heated as it rises up through and comes out the top as heated air, so it actually produces heat. You can see here where the fresh air is going in and the products of combustion, typically carbon monoxide and water vapor, are going out. Pretty simple application, actually. Here's a real example, a real life example. We have our direct vent here. We have our gas line coming in. This is going to be our chimney chase. It doesn't need to penetrate because this is the access. This is the intake and output source right here. Pretty typical to see these on condominiums, for example. The close-up, the blue arrows represent cold air going or fresh air going in, and the red arrows represent the products of combustion coming out. This metal, by the way, gets very hot. So if you're inspecting these things, you should not make contact with them if they're being operated, because you will get burned. Another example of intake and exhaust. Pipe diameters are usually anywhere from 2 to 3 inches. Very typical at 2.5 inches. Typical separation between the intake and the exhaust should be a minimum of 18 inches or more. You don't want them too close together. Where you have appliances and intake and exhaust ports, there should be a minimum of 10 feet apart. You can see right here that that's not the case. That's more like 5-6 feet. These are manufacturing specifications, by the way.
Hey, Mike, real quick, what's your opinion on those screens about going over those vent pipes to keep vermin out?
I don't run across them in my market area, so I really don't have an opinion. If the manufacturer says they're okay to use, then I would be comfortable with that. But I've yet to see that in any specifications where they actually address that issue.
Yeah, I see them sometimes pressed inside the piece of PVC pipe just to keep critters and birds from going in there.
But that's a homemade job. That's not a.
Oh yeah, totally. Yeah.
Now the thing to remember when you're dealing with wood frame walls is these should never be indented in the wall. They should always terminate the surface of the siding, because they do get very hot and they need that exposed outer air in order to get rid of that heat that they're producing. So if you ever see them indented, typically you would see that on a wood frame wall. If you ever see them indented, that's improper installation, and it's also a health and safety issue because it could ignite. National Fuel Code for direct vent clearances.
Hey, Mike.
Yeah.
Let's back up for a moment. The PVC pipes have to be 10 feet apart But that unit coming out the wall on the Chase, you said goes on condominiums and so forth. They're right next to each other. Why is the difference?
Hold on, let me get my picture back.
Intake and output.
You talk about this picture here?
Yes. That's not 10 feet.
No, but they are separated by a baffle right here. And if you have the ability to look inside, you're going to see there's a physical separation between the blue or the fresh air going in and the products of combustion coming out. These are these are manufacturing specifications.
Yeah, I understand that, but I mean, by 10 feet on the pipes, you could put a piece of aluminum, pop rivet or screw or piece of aluminum to the end of a pipe, and it would be a separation.
That's possibly true, I assume. But yeah, I've never heard of that happening, but I suppose it could. Now,
Well, I mean, if that little piece of aluminum on this picture is a separation, then certainly anything can be a separation.
All right, so
I was just wondering.
Let me interrupt for just a minute. Let me remind people that if you have questions, please put your questions in the chat, please.
Oh, okay. Sorry
Sorry.
about that.
Yeah,
that's all right. That's all right. We enjoy questions. That's how we educate ourselves. Now, in these circumstances, you're more likely to have issues where this might be sucking other than fresh air, or it might be sucking fresh air plus something else. So that's why the separation is much more important.
I think he's talking about the picture that had the condenser where you showed a 10-foot line that they were
Right here.
10 feet from the condenser, right?
This one here. Any questions? What?
I think he was confusing the 10-foot being the intake from the exhaust versus the condenser.
No, I'm not confused. I wonder why one has to be 10 feet and one of them is a quarter of an inch.
This is your exhaust port. This is your exhaust port here. You don't want to have this exhausting products of combustion being sucked into your AC.
I understand. You're talking about it has to be 10 feet from the AC, not the combustion air taken in for the unit.
Exactly. And it's not necessarily just the AC, it's any appliance that has the ability to circulate air.
Okay. All right. I got you now. That's
Okay.
That's the difference there. Thanks.
You're welcome. So I'm not going to spend a lot of time. You guys can read this, or you can watch the video later, or you can take snapshots of these PowerPoints, these slides if you want. I have no problem with that. But typical distances, the intake from the ground to the intake should be no less than 12 inches. Now, if you're dealing in an area where there's a snow load, you might want to rethink that and make it higher. And that's going to be something that's going to be local to your inspection area. Distance of permanently closed windows, 12 inches. From ventilated soffits, roof eaves, overhangs, things like that, 2 feet. Unvented soffit, 2 feet. Outside corner of a building, I'm not sure why this makes a difference, but they want to see it at least 24 inches from the outside corner. From the inside corner, at least 3 feet. Must have to do with circulation, I assume. Distance of gas service regulator, 4 feet. That makes a lot of sense. You don't want those two interfering with each other. Distance to a non-mechanical air supply inlet to the building, 12 inches. To a mechanical air supply inlet, 3 feet. Above a paved sidewalk, 7 feet. Obviously, that's going to be where foot traffic is. Distance below a balcony, deck, porch, so forth, 2 feet. And here's a schematic of what I just talked about. And if you line up the letters that you see here in various locations and come up here and take a look at what it says, it kind of reinforces what we just covered. This would be a great picture to have when you're inspecting because you could refer to it. Now, these numbers are not written in stone. These numbers I just talked to you about. They're predicated on the following. Whether it's direct vent or non-direct vent, that's going to change those numbers. Whether it's dictated by the local authority having jurisdiction. The local jurisdiction has a lot to say about what kind of numbers they want to see in their area. Whether the manufacturing specs say otherwise. Different manufacturers are going to have different specifications. Okay. Whether it's this country or Canada. Canada is very very different numbers from what we use here in this country. I don't know why, but they do. And whether it's the gas code or local code. So all of these are going to affect the numbers you're going to run into in reality while you're traveling through your inspection area. And you want to follow those numbers, but the ones I gave you are just a relative reference.
Hey, Mike.
And that's it.
Hey, Mike,
Yeah,
I had a
yeah.
question. How does a direct vent through the roof differ from a regular appliance vented through a chimney?
How does a direct vent through the roof do what again? I'm sorry.
Differ from a regular appliance vented through a chimney?
Well, it may not have, because it's through a chimney, it may not need its own intake, fresh air source. The fresh air source may come from a vent in the chimney itself. You understand what I just said?
Yep.
Okay. And I think some manufacturers allow you to do that. I know local jurisdictions allow you to do that all the time. Any other questions?
Nope, that covered it.
I appreciate it. Thank you.